Hello everyone, welcome to my YouTube channel. Today in this video, we shall continue from the previous part. Actually, in the previous video, the geometry of the structure has been defined here in Perform 3D. The frame, the grid line, the story, etc. are defined from this tab. So, if we have to go for the story like grid AA, grid BB like this, and every section, every story the frame section can be utilized to add or delete the frame grid like in the tabs. So today the application of the mass source in this node option. Actually in Perform 3D there are two phases of uh, working. The first one is the modeling phase and another one is the analysis phase. Most of the works, most of the modeling part, assigning the loads, etc. are done in the modeling phase, and the application of load cases, analysis, the structure are done in this phase. Also, the extraction of the results are done in this phase. So here, at the first or starting point, we have to start from the node points. So the nodes has already been assigned and the geometry of the structure has been defined in Perform 3D. So after that, the supports of the structure have to be assigned. Like in ETABS, at the base of the structure, this is the fixed support. We assign the uh, joint restraint at the base of the structure as a fixed support. Here, this is the dialog box for assigning the restraint. If we select this one is the fixed support, this one is the hinge support. Hinge support means translation X, Y, Z, and this one is the rotation X, Y, Z. And if we select for roller, this one is the roller, it means translation Z, and this one is the free. Similarly, in Perform 3D, there are many options. So here, if we choose the base of the structure, and we can select the node at the base of the structure, for each node, if we put fixed for 6 degree of freedom for the node 12, this one is the fixed support. For example, if we have to assign the hinge support, then we have to go for this as like in tabs. So this one is the hinge support. And also if we have to assign the roller support, we have to go for this one vertical displacement. And if we select some nodes, let's now I will select this node. Yes, this one is the roller. And for example, another hinge support like this. Yeah, this one is the hinge support. This is the roller support, this is the hinge support, and this is the fixed support. And like this, we have to assign the support condition for the structures for the base or any other places if we have to assign the boundary condition. So after this, we have to go for assigning the mass. First of all, let me introduce the name of the mass source. Let me say dead load plus 0.25 live load. Okay. Then we have to specify the weight or masses and optional tributary area like H1 translation or 3 degree of freedom for translation and 3 degree of freedom for rotation. Simply 6 degree of freedom at the node. This can be applied in different way. The first way, the simple way is to import the structure from etabs, and the mass source can be assigned to each node of this structure. And another way is to insert the coordinates, and we have to calculate the seismic weight of the structure or lump mass. We can say it's lump mass at the story level. We have to assign the coordinate, and we have to input the coordinate here at each story level and input that mass system, a lump mass. And another way is to import the coordinate as well as the lump mass system as a CSV or comma separated file or text file, which can be generated in tabs. So I'll try this one. So let me check in tabs. If we run the structure, first of all, we have to analyze the structure to generate the story mass by diaphragm and export that message into Excel, CSV file or text file, and import that files into the Perform 3D, which is compatible in Perform 3D. So here, if we see the display table, and we have to go for other definition for mass data, then click mass summary by diaphragm. Let me check. Yes, these are the masses uh, summary by diaphragm. So let me export this mass to Excel sheet, and I will convert this into CSV file. So the Excel sheet is generated here. Here, these are the story diaphragm, story 3 to 1, mass in x direction, mass in y direction, moment of inertia, and center of mass in x direction, as well as the center of mass coordinate in y direction. So we have to convert this file. We have to convert this file into the compatible file for Perform 3D. So if we look into the Perform 3D, here is another tab which is import and export. Here we have to import from this import structure data. Now first of all, we have to import the node only. So for the node to be imported, each line must have h1, h2 and b coordinates of the node, and may also have the load or mass. Node must be set off before load or mass have been imported. So first of all, we have to import the nodes for the diaphragm masses, and after that we have to import the masses or load. So let me make that Excel file compatible to this type, to the Perform readable file. So here, first of all, we have to assign the coordinates. So I will make another sheet here. These are the XY coordinates, and let me go for Z coordinate. It is called H1 direction coordinates, S2, or simply we say H1 translation, S2, H1, S2 and Z. For Z coordinate, if we check the coordinates of the structure, it means 3 meter, 6 meter, 9 meter. So for story 3, first is story 3, this one is 9 meter, this one is 6 meter, and this one is 3 meters, sorry, 3000 mm, 3 meters. So these are the XYZ coordinates. So after that, we have to go for H1 translation, another one is S2 translation, third one is B translation, another fourth one is H1 rotation, S2 rotation, and finally B vertical rotation. So here we have to copy the masses in XY for this one, and this one is 0. We have to input 0. There is no any value for vertical translation. So similarly, H1 rotation is also 0, and S2 rotation is also 0, and the value given in ETABS is moment of inertia, which is called V rotation. This value is rotation along the Z direction. Okay, so let me save this. I have to save for command related value coordinates, then I will put in somewhere in my PC. So I'll choose desktop. Okay, I'll delete this one. Yes, I will delete this one. And at the time of copy the files, or after extracting the or importing the file into ETABS, sorry, Perform 3D, we have to skip first two lines. Okay, so let me import this coordinate CSV file here with the help of import option. Here, go to nodes only, and I browse the location, which one is coordinate, which I recently saved, and we have to skip first two lines. I already mentioned that in CSV file. Then this file contains load or masses. Yes, let me test. Okay, the operation is complete and number of nodes read by this perform 3D are 3. It means 3 coordinates for each story. It means story first, story second, and story third are already read here. So I will check OK. Then I will press OK. So these are the coordinate for the diaphragm masses entries. So again, let me check for masses. Then I have to browse. So already came here. We have to skip two lines. Then let me test. Okay, the masses which have been assigned, which have been copied in CSV file has been read by this software with the help of importing the comma separated file. So let me check. Okay. Okay, so after doing this, we have to update the story level because if the story at the story level, the coordinates for lumped mass has been assigned. So we have to assign this coordinate in each story. So if I go to frame here, let me go to story one. Then let me check this. So let me convert this 3D into this elevation, either S1 or S2. Then for the story one, other nodes has already been selected, assigned, and the remaining node is the last node we had just assigned for uh, lumped mass system. So this is updated. And similarly for story two, there is also only one value. And similarly for story three, there is also one value. So this is the point where in ETABS we saw the diaphragm like this. Yeah, like this we assigned for these coordinates. So after this, we have to go for constraint. In ETABS or other FEM software, these are the diaphragm, either assigned either by the help of joint or with the help of cell diaphragm or with the help of joint diaphragm. So in perform 3D, we have to first define, let me say D1, which is horizontal rigid floor. This one we have to choose this first option in our case. And if we go for story one, okay, so let me select this and assign the diaphragm to story one as D1. Again, let me define another one for story two. Let me set D2. Then we have to go for story two, this one, and select. And finally, D3 for story three. Select these nodes. We have to go for story three, select these nodes and check. Okay. So the complete works for node element support, mass, and constraints has been done in this model. And in the next video, we'll continue from here. It means we will assign the properties of the elements and load, and finally run the structure to obtain the model properties of the structure. So as compared to ETABS, the modeling in Perform 3D is a lengthy and it's a tedious process. So we have to follow each and every process precisely and model the structure. Till then, keep watching my videos, be safe and stay healthy. Thank you. Bye bye.